Hello, my name is Zaki Taufikul Hakim and my NPM is 2006518243. I'm from the group 5 and I will be explaining about the limit and continuity.
Hello, my name is Fadil Mahputra Santoso. My student number is 200-651-8262. I'm from Industrial Engineering, batch 2020.
Hi, my name is Rifat Firas Aiman. My student ID is 2006518400. I'm from group 5 and I will be explaining about partial derivative.
Hello, my name is Mark Furqan and my NPM 2006518331. I will explain about partial derivative.
My name is Bagas Tegar Badriviata and I'm from Mechanical Engineering, and I'm here to explain the definition of multivariable function. A multivariable function is just a function whose input and or output is made up of multiple numbers. In contrast, a function with single number inputs and single number outputs is called a single variable function.
Moving on to the next topic, that is partial derivative. In short, the partial derivative is a change in the value of a function that has two variables. For the definition of a partial derivative, suppose that f is a function of the two variables x and y. If y is held constant, for example y equals y0, then f x comma y0 becomes a variable of x. The derivative of x equals x0 is called the partial derivative of f with respect to x in x0, y0, and expressed as fx x0, y0. The function derived with respect of x. This means that the x will change and the y will be constant. Vice versa to y, if the function derived with respect to y, the x will held constant and the y will change. So I'm going to give a problem example here. It is fx x squared y. It can be derived with respect to x and y. So if we derive with the function of x first, the result will be 2xy, and we can prove this by using a limit. As we all know, fx x comma y equals to limit approaches h approaches to 0, fx plus h comma y. As we all know here that the function derived with respect to x, the x will change and the y held constant, minus f x comma y, the function over h, and then we put it in the real form, which is this x squared y. So we put exponent here times y minus x squared y, the function. Then we'll calculate it and then we eliminate it. At the end of the result, we substitute h with the 0 and left us with 2xy, and it is proven by using a limit. The same goes to y. If we derive for the function of x, the result will be x squared, and we can prove this by using a limit. As we all know here, x comma y is plus h, which means that the x is held constant and the y is changed. Y changes, and then we'll calculate it, eliminate some, Then we got the result here, and it is also proven by using a limit.
This is an example of a simple partial derivative problem. If z is equal to x squared plus 3xy mean y squared. If we are looking for the partial derivative of dz per dx, everything that is missing x is a constant. Likewise, if we are looking for the partial derivative of dz per dy, everything that is missing y is a constant.
So in this slide, I will explain about limit and continuity. It will be the definition, theorem, and the problem example. So what is the limit of a function of two variables? In simple words, it means that the values of x, y get closer and closer to the number L as x, y approaches a, b. And from this definition and visualized by this graph, we can intuitively see that there are several aspects of this definition. First, the path of approach to a, b is irrelevant. This means that if different paths of approach lead to different L values, then the limit does not exist. Second, the behavior of f, x, y at a, b is irrelevant. The function does not even have to be defined at a, b. This follows from the restriction 0 less than absolute x, y minus a, b. Third, the definition is phrased so that it immediately extends to function of 3 or even more variables. Simply replace x, y and a, b by x, y, z and a, b, c wherever they occur. So I'll be explain the three theorem of limit, which is theorem A, B, and C. This is the first theorem A. As you can see at this slide, if f, x, y is a polynomial, then the form of the limit will be limit x, y approach a, b, f, x, y is equal to f, a, b. And if f, x, y is equal to p, x, y divided by q, x, y, where p and q are polynomials, then the form of the limit will be limit x, y approach a, b, f, x, y is equal to p, a, b over q, a, b. And then if provided q, a, b is not equal to 0, furthermore, if limit x, y approach a, b, p, x, y is equal to L and not equal to 0, and limit x, y approaching a, b, q, x, y is equal to 0, then the form of the limit will be limit x, y approaching a, b, p, x, y over q, x, y, and it does not exist. Next, the theorem B, composition of function. If a function g of two variables is continuous at a, b, and a function f of one variable is continuous at g, a, b, then the composite function fog defined by fog times x, y is equal to f parenthesis g parenthesis x, y is continuous at a, b. Theorem C, equality of mixed partials. If fxy and fyx are continuous on an open set S, then fxy is equal to fyx at each point of S.
So we now have this problem. Limit x, y as it approaches 0.0 of tan of x squared plus y squared all over x squared plus y squared. How do you solve this? We can solve this by substituting tangent with sine over cosine. So we can change the tangent to limit x comma y as it approaches 0.0 of sine x squared plus y squared all over x squared plus y squared, there's nothing changed there, times 1 all over cosine times x squared plus y squared. So we now know that limit x comma y as approaches 0.0, we can substitute this to x and y. So for this part, sine x squared plus y squared, we can substitute it 0, so this will become sine 0 divided by x squared plus y squared. This will also be 0, but we also have learned that limit x approaches 0 for sine x all over x is equals to 1 times 1 all over cosine x squared plus y squared. Now we substitute 0 to x and y. So now we have cosine of 0, which is 1. So now we have 1 times 1, which is equal to 1. The next problem is limit x comma y as it approaches 0.0 of x times y all over square root of x squared plus y squared. So how do we solve this? We can solve this by changing it to the polar coordinate. So we know that x is equal to r cosine theta and y is equal to r sine theta. And we also know that r is equal to square root of x squared plus y squared. So we just substitute them with r cosine theta times r sine theta all over r. Then we can cancel the r from both sides. So now we have r cosine theta times sine theta. And then we can substitute 0 to r, which will be equal to 0. So that's the answer. Thank you so much for watching.